Okay, we are at the top of the hour. Let me get us going here. There it is. Okay. Hi, everyone. Thank you for attending session 4B, Complex Data Challenges at the RDAP Summit 2024. My name is Matthew Harp. I'm a Research Data Initiatives Librarian at Arizona State University, and I'm the moderator for this session. This is a Zoom webinar. Attendees are muted and your cameras are turned off. Please use the Q&A located at the bottom of the screen to ask questions. The session runs from 2 to 3 p.m. Eastern Time, with the last 15 minutes at the end for questions and answers, where you'll be able to ask questions of the presenters. Please indicate the presenter or presenters to whom you would like to direct your question. We'll save all the questions until the end of the session. After the session, please feel free to drop questions and continue the conversation in the session chat and feed loop. The Research Data Access and Preservation Summit organizers are committed to providing an environment where all attendees can participate fully in the program and activities without fear of harassment or discriminatory behavior of any kind. There is a code of conduct helper available during the session. Emily Kilser, they are identified as the COC helper in Feedloop and in Zoom, and you may direct messages to them in Feedloop if you need assistance. They can give you the code of conduct email address or the link to the incident report form if needed. And now let's get going. First, we will hear from Jessica Coe and Kelsey Norick from the Roper Center of Public Opinion Research, presenting Converting Collections Takes a Community, Facilitating Historic Data Conversion Projects. Take it away.
Hello, I'm Kelsey. Jessica and I are senior curators at Roper. And the Roper Center is a nonprofit organization founded in 1947. It's the oldest social science research archive and the largest specializing in public opinion data. We have over 37,000 data sets and 865,000 questions in the archive, with data going back to the 1930s. Of these studies, over 9,000 have not yet been converted to modern data formats. This includes over 5,000 data sets that are still in column binary format, which is a file format that was commonly used from the 1930s to the 1960s. Today, we'll be discussing Roper's strategies for converting our collection of column binary studies so that these historical surveys are more accessible for researchers. For those who aren't familiar, column binary files were used to store survey data from punch cards, which are paper cards in which holes are punched to represent data points. There are different types of punched cards, but the 80-column IBM card is one of the most common. The columns represent variables, and the rows represent possible responses. There's space for 12 possible response values, 0 through 9, plus space for additional punches directly above the 0. In this example, the column location for question 7 is 37, and the numbers 1 through 5 indicate possible responses to the question. If a respondent were to answer labor to this question, the card would have a punch in row 2 of column 37. In column binary files, each bit represents a single data point, unlike today's formats, which use 64 bits to represent a single data point. This means that the column binary files cannot be read by modern computers. They have to be converted and imported into a statistical program as raw data. One way to do this is by using SAS code to create an SPSS file containing the raw data. The raw data is then recoded, labeled, and cleaned according to the survey codebook, which provides information about which column the variables are stored in and how the responses are coded. After the conversion is completed, the frequencies are checked against available documentation. If no published frequencies are available, common sense checks may need to be used. For example, if a question asked about a respondent's preferred political party, it would be reasonable to expect that the percentages would be similar to preferred party data from other sources around that time. And it might be a red flag if a minor party corresponded to the highest percentage of responses. So column binary conversion is a complex process, and we've utilized a variety of approaches for converting our column binary datasets to modern formats. This includes in-house conversions, collaborating with external institutions, and developing training resources for the broader research community. There are several staff members at Roper who are trained in column binary conversion. We complete conversions on data sets that have been identified as high priority due to potential research interest, and we also complete conversion requests from users. Having staff with expertise in column binary conversion is extremely valuable. That being said, column binary conversion is a very time-consuming process, and so our staff bandwidth limits the number of conversions we're able to complete. One way we've lessened the time burden on Roper staff is by offering users who are interested in a column binary study the option of receiving a conversion package for the study. So we'll complete the initial conversion step of importing the data into a readable format, and then we send the raw data along with the study documentation and instructions for completing the conversion. We've been hard at work chipping away at the column binary collection at Roper, but given the size of the historical collection, it would take many, many years to convert them all if we were to just rely on our internal resources. So collaborative projects with external institutions are an excellent way to efficiently convert large numbers of column binary studies. For example, we collaborated with the University of Southampton in the UK on a 3-year project funded by the Economics and Social Research Council. And this project came about when Southampton researchers found out that there one in the Roper Center archive, but most of the data sets for the surveys were only available in column binary format. Additionally, many of the codebooks for the studies were only available in paper format at the Roper archive. The Southampton team identified surveys for conversion based on research interest, and the Roper Center team created conversion packages and provided training and support to the Southampton team as they completed the conversions. We also contracted with the digitization firm Trigonix to digitize the paper documentation. By the end of the project, more than 2,000 British Gallup survey codebooks were digitized, and over 700 British Gallup poll datasets were converted to modern data formats and made available through Roper. And now I'll go ahead and hand things over to Jessica for the rest of the presentation.
Thanks, Kelsey. Okay. So we've also trained outside institutions such as the National Archives and Records Administration on how to convert column binary files. Sometimes an arrangement like this may involve, for example, providing the institution with the desired column binary files from our archive for free, with the understanding that the converted files would be shared back with us. This not only benefits us, but the requesting institution as well, since while Roper is a nonprofit organization, we do operate on a membership basis to maintain our staff and operating costs and charge for individual data access to institutions who do not wish to purchase a full membership. Other times, training arrangements may not involve data exchange, but may instead focus on building intra-institutional relationships and promoting sharing of information within the data community. Increasing visibility of our unconverted column binary collection is another of our targets. One of the ways we hope to accomplish this is by enabling the use of search terms. Presently, Roper iPulse search capabilities for the column binary collection, some of which are shown in this picture, include filters for items such as the survey interview dates, the country in which the survey was conducted, the survey organization, and the file type, along with a few others. But many in the collection do not yet have keywords or phrases or tagging implemented, making it difficult for people to find historical data they would like to have converted based on topics of interest. Another target for increasing visibility is to create finding aids, perhaps one for each survey organization's column binary collection, for example, so that people can have an idea of the contents. And finally, while many archivists understandably cringe at the familiar query of why don't you just digitize everything, it's actually an achievable goal for a mostly digital archive like ours that has only a relatively small collection remaining in paper format. With the help of student labor, this could be accomplished in less than 10 years and would enable researchers to view survey contents for themselves and identify topics of interest with more precision. These, of course, are all contingent on funding. In addition to conducting trainings and working toward increasing visibility of the collection, we have sought to prepare materials to facilitate independent learning. In the interest of furthering this initiative, Kelsey and I published a column binary conversion primer this past year through the Data Curation Network, available at the link shown here. This primer includes an overview of what column binary is, why it needs to be converted, and how it can be converted using our current methods. However, these current methods do present obstacles for researchers in various ways, including difficulty to learn and master the process and necessitating proprietary statistical software such as SAS, SPSS, and/or Stata, which can be prohibitively expensive for individuals or even institutions. Because of these obstacles, we're working toward improving and simplifying our processes. We are currently working to build an R package for conversion, which will enable free access through R's open source program. In doing so, we're also looking to streamline and revamp our syntax to minimize the frequency of having to puzzle through decisions and tediously type things out as best we can. And thank you all so much for your time. And please feel free to contact us if you have any questions you can't fit in the Q&A. Thanks.
Thank you. Next up is Creston Miller and Ladale Winling from Virginia Tech presenting Identifying Patterns of Racial Discrimination Through Natural Language Processing. Take it away.
Okay. You see my screen all right? Oops.
Yep, we see your screen. Just
Okay.
need to go in presentation mode.
Yeah.
Yep, that's it. Perfect.
Whoops.
There you go.
Maximize. There we go. Excellent. So thank you everyone for coming today. I'm Creston Miller, Assistant Professor at the University Libraries at Virginia Tech. And I'll let Ladale introduce himself.
Hi, my name is Ladale Winling. I'm a history professor at Virginia Tech, and I am the project director for the Chicago Covenants Project. So next slide, Preston. Racially restrictive covenants are documents created by the real estate industry and used on a widespread basis in the first half of the 20th century. And essentially, it's a legal document that are either established by real estate developers when they create a subdivision, or one signed by neighbors and residents who live in a neighborhood that promises, obligates them never to sell, lease, or allow residence by someone from a prohibited group. In Chicago, 99% of these restrict African Americans, but in other places around the country, other largely minority and especially immigrant groups prominent in that region are restricted. And so in an effort to document these kind of patterns of racial segregation and the connection between racial inequality and real estate, we have been searching for to identify these in Cook County, Illinois, in the Land Records Office. And I'll handle the kind of background of the project, and Creston will talk about our collaboration and how we're basically working together to treat these documents as data, not just as historical sources. All right, so next up, Creston. I want to say, because these are documents of discrimination, and were intentionally used as such, we deal with the kind of historical terms, and can often maybe be like fairly uncomfortable. Go next. So these documents, like I said, range from use largely in the first half of the 20th century, mostly from the 19 teens until about 1950. They were widely used, so widespread that I would say there is almost no community that existed in the United States by 1950 in which there were not racially restrictive covenants. They are promoted by the real estate industry. And so they're voluminous. But they're so widespread, they can be difficult to identify. I would sort of say, at one point I said that it was like finding a needle in a haystack, but it's actually like finding hay in a haystack. That is to say, finding particular pieces of hay, because they're almost indistinguishable in the archives. Cook County is the home of Chicago, Illinois, which was also and remains the kind of real estate capital of the United States. The National Association of Realtors is based there, and its predecessor organization, the National Association of Real Estate Boards, helped kind of create real estate as a profession, created real estate appraisal, and spread these practices from Chicago all around the country. And these kind of were curtailed in 1948 with a Supreme Court decision, but there were some attacks upon it and challenges against racial covenants throughout the 1920s, 1930s, and 1940s, and particularly one in 1940. Hansberry versus Lee, and that Hansberry is the father of Lorraine Hansberry, who wrote the play A Raisin in the Sun, in part drawing upon her experiences as a youth in Chicago. Next slide. So here's an example of a racially restrictive covenant. It's usually kind of like a 5 to about 25-page document, but some of the key language here you see in the document on the left is kind of emphasized on the right. These are restrictive clauses, the restriction that no part of said premises shall in any manner be used or occupied directly or indirectly by any Negro or Negroes, from the first clause. Second, no part of said premises shall be sold, given, conveyed, or leased to any Negro or Negroes, et cetera, unless like in a service capacity. And so there's so many of these, thousands in Chicago, which cover tens of thousands, probably hundreds of thousands of lots. It's basically impossible to do the traditional analyses of these and interpretation that a historian would do. And so, working with Creston, we've tried to think about ways to use natural language processing to kind of identify some of the patterns of change and some of the spread of practices across Chicago, and then ideally to other places across the country. Next slide. And two of the kind of key aspects that we're interested in are the changing nature or definition of who counts as an African American. In one period, in an earlier period, anyone who is 1/8 African ancestry is subject to exclusion. But I think after the Hansberry versus Lee case and decision in 1940, that restriction goes to 1/32. So from like one great grandparent to like one great grandparent, puts someone at the risk of exclusion. And that's as a result of the people who were involved in the Hansberry versus Lee case. And we're also interested in how that format or the particular legal restrictions and penalties change over time. And so with thousands of documents, we're kind of interested in what natural language process can do for us in assessing these patterns, both by geography and across years. And with that, you can take it away, Preston.
Okay, thank you, Liddell, for that great intro to this, background information of these documents. And these documents themselves, I'm going to start talking, point out some of the challenges with them. They were microfilmed in the 1980s, and our team at Virginia Tech recently scanned them at a high resolution. But due to the age of microfilm, there is fading, and this fading can make lines thin, sometimes very weak, or even create breaks. And the background of the scans are not quite white or near white, so there's less contrast, which makes performing optical character recognition, or OCR, more challenging. So I have a few examples on the bottom of some the words that were from these documents. We have from left to right: use, become, and occupant. You can see different breaks and things in the words themselves in the print. And next we'll see on the left is a single page scan overview. You can see there's fading. And we zoom in on the top right, you can see a paragraph, see kind of the quality, and zoom in some more on the bottom right. You can see that the quality is not the best. The background is a little hard for distinguishing for a computer because of less contrast. And so we were using the OCR software, Visual NLP from John Snow Labs, and they have built in what they call visual transformations. It's operations you can do through computer vision on the images themselves. And so we developed through experimentation this pipeline where we take the image, we scale it even closer 2 times. We perform something called a median blur, then adapt with thresholding, and then invert the image colors. And there you can see the result on the right. I'll go through each of these steps. So first, we scaled by 2 times. Since we have high resolution, we're able to go in even further and get, and so with that, because we have some of the text is thin or breaking, we perform something called a median blur, which thickens the lines a little bit more. And as a highlight here, you can see the word hand becomes a little more bolder, which makes it easier for an OCR to recognize. And then from the median blur, at the top, we go to the bottom of this slide, which is adaptive thresholding, which is able to pull out and distinguish some of and threshold the background from the text itself. And it makes the text pop a little bit better. And we tried to perform OCR just on this result, and it did not do as well as we had hoped. But interestingly enough, after we did the thresholding, we did an inversion of the colors. So black background and white text. And that made it pop even more. And the OCR worked very well with that. As we'll see in an example here, top is the final output of the pipeline, and the bottom is the OCR results. Now, there are a few errors, but I want to point out No, even some text that didn't come through quite right, like I have highlighted paid and acknowledged, it still was OCR'd correctly. So this pipeline was working very well along with the OCR library working great too. And so here's a cleaner example with respect to the scan being a little more, plays more nicely with the OCR technology. And we can see on the left that the scanned image blown up on the top right. And further down on the right, we can see the final OCR, which might have an error or two here, but it does pretty well. Now, what can we do with this? In the spirit of RDAP this year, the data interoperability and accessibility aspects, now these covenants are more accessible. They're machine readable text that we can now operate on, make available. We can perform some different kinds of analyses that provide other formats to bring insight, and ultimately, in our case, begin to address our research questions that Ladale mentioned earlier. And so that is looking at identifying specific language usage of these covenants, specifically defining racial segregation. And in natural language processing, taking two texts and trying to compare them actually is a little challenging to do. And so one approach that we have tried is the first one so far, and it is taking the covenant text that was extracted and pulling apart at the sentence level, because there is something called a universal sentence encoder in natural language processing that can take two sentences and compare them and see how conceptually similar or dissimilar they are. And so we're able to use this visualization technique called TSNE that takes the output of the universal sentence encoder and plots it on a 2D space, where each dot on this space is a sentence. The closer the dots are in this 2D space, the more conceptually similar that they are, and the more that they are talking about the same thing. And so this ended up being working really nicely, because we can see all these nice little clusters, and these are pieces of the legal documents that are talking about the same thing. So that therefore there's a similarities right there. The differences come when the sentences are kind of a little further away from these different clusters. And those we can focus in on and see, okay, what's going on here? And one thing I want to point out with this black oval is this section is what I call OCR junk. There's things that were errors in the process, and thankfully we were able to nicely kind of cluster everything into one place and filter it out. So one thing, lessons learned and observations in this process was we had to experiment with these visual transformations. I did a number of hours trying to figure out a good pipeline. The high resolution scans required a lot of computing resources because they were so large. And the OCR performed well enough, this particular one, that the correct categorization of sentences was able to be performed. And so for future work, we'd like to do some spell checking to help normalize the OCR errors. We would love to have some type of search functionality either within the visualization or the output, so we can help us narrow down on the pieces of the covenants that we're interested in. Looking potentially at what's called word co-occurrence networks, seeing how words are used across the text. And also importantly, more covenants, allowing this so we can actually get more information in there, look at the trends, and help us look at investigating that racial definition clause and help us understand what was going on. So with that, I say thank you.
And thank you. All right, now we will hear from Sybil Schaefer from UC San Diego presenting It's the End of the World as We Know It, and Your Data May Not Be Fine. It's all yours. Sybil, you're muted.
Thank you. I wanted to start off a bit with discussing a bit about digital preservation and my observation of something that gets mentioned quite a bit as part of the data curation process, but the particulars tend to be glossed over. So digital preservation combines policies, strategies, and actions that ensure access to digital content over time. And I really like this definition for two reasons. The first is that it centers the work in policy, strategies, and actions, and not in technology, which you'll notice is not even mentioned. There's a common misconception that digital preservation is all about strategy, but technology is just a tool. You can do digital preservation without a digital preservation system, but you can't do it without the policies that govern the work, strategies that mitigate risk, and preservation actions. And the second reason I like this definition is because it highlights access, which people also tend not to think about when they think of digital preservation. But yes, the point of preserving is to preserve access to materials. And preserving access includes preserving renderability, preserving context, and preserving authenticity. Like many activities, digital preservation is most successful during times of organizational, financial, and political stability. During the last few decades in which this niche professional area has grown, the United States has experienced fairly consistent financial and political stability. And by this, I mean we haven't fought any wars on US soil or had any economic depressions. Basically, no events that have had a long-lasting destabilizing effect. And lastly, it's important to note from the outset that when we say we are going to preserve something, we're also saying that we're going to make an ongoing commitment to energy expenditure and resource extraction. And there we go. So at its heart, digital preservation is risk assessment. We evaluate risks and then implement strategies to mitigate them. These are the commonly understood threats to digital materials that we try to mitigate, and I'm actually going to revisit this in a later slide, so I'll skip it right now. These are strategies for digital preservation, the common strategies. I'm going to touch on a few of them that are particularly pertinent to this talk, and they include data migration. So that's migrating from older or obsolete file formats to newer, widely supported ones. And this can be file formats and storage media as well. Fixity and authenticity are extremely important for preservation. So we record fixity information to prove authenticity, and we regularly check for alterations to the data. Replicating independent copies. So independent copies means that any one event, agent, or technology can't result in irreparable data loss. The preservation system that I manage has 3 geographical distributed nodes across the United States. There's no single person that can access the data at each of those nodes. They're also geographically separate. So any disasters, et cetera, will only affect one of the nodes. And then lastly, the technology that we use at them is the stacks are a little different. Metadata is extremely important for providing the contextual information needed for preservation. And then lastly, one thing that's not talked about very frequently, but I'm going to touch on is encapsulation, which is packaging the important metadata and materials together. So digital preservation requires resources and energy. Digital storage requires plastics, which are made from petroleum and natural gas, and metals and minerals, which are mined from the earth. Mining for minerals and metals often takes place under grueling conditions in the global south and leaves the local environment polluted and poisoned. Every 5 years, when our storage warranty runs out, we move to a new storage system, thus incurring the need for more materials. Digital preservation storage also requires energy, sometimes a lot of it. As an example, the cloud now has a greater carbon footprint than the airline industry. A single data center can consume the equivalent electricity of 50,000 homes. In addition to the resources that are required for digital preservation, we should also be aware of the waste it creates. An estimated 50 million tons of electronic waste or e-waste are produced globally each year. And according to the World Health Organization, only about 17% of it is recycled. The waste is hazardous. It contains toxic materials such as dioxins, lead, and mercury. which also pollute the environment where they're disposed. Children are often involved in waste picking and scavenging, and also in recycling the materials because their hands are small and it gives them an advantage. So last year I started conducting a deep dive into climate change because I was talking about risk mitigation, and I realized that there hadn't been much exploration into the risks that climate change poses to digital preservation activities. So what happens when the world warms? Extra heat in the atmosphere causes increased sea levels, higher ocean temperatures, increased risk of wildfires, extreme and more frequent weather events and disasters, droughts and water scarcity, the collapse of ecosystems and biodiversity, disruptions in food production and distribution, mass migration, disruption in global financial markets, and finally, an increase in conflict and political upheaval. According to the IPCC, every increment of global warming will intensify multiple and concurrent hazards. So I took the list of common threats to digital preservation, which I showed earlier, and mapped the effects to climate change to each one. This isn't necessarily exhaustive, but it provides a glimpse of the potential futures difficulties that we'll have in preserving. So natural disasters, they're going to be more frequent, more severe, and concurrent. Network failures, there's one study that says by 2035, 4,000 miles of coaxial internet cable will be surrounded by or underneath water, and 235 data centers will be flooded by sea level rise. This is US-based, and it's predominantly in Miami, Seattle, and New York. Internal and external attacks will be increased by the increase of conflict. Loss of context, which is essentially the metadata that you need or the information that you need to make sense of the materials. If there's contraction in economic contraction and budgets are cut, there'll be a decrease in funding for curation activities. Organizational failure can be affected by economic contraction, increase in political conflict, sea level rise depending on the location of the organization, increase in concurrent disasters, as well as disruption of food production and distribution. And then finally, loss of will is essentially when the organization or individual decides not to preserve any longer for whatever reasons. And that can be caused by a number of reasons as listed as well. So when I first wrote my proposal for this conference, I noted that we were projected to hit 1.5 warming by early next decade. This was before the headlines started rolling in about how last year was the hottest year on record. And although IPCC temperatures are averaged out over 20 years, there is growing consensus that we are in the realm of 1.5 degrees Celsius warming. Renowned climate scientist James Hansen, who delivered landmark testimony to Congress in the late 80s on the dangers of global warming, thus bringing it to the public's attention for the first time, published an article last fall, which claims that we will exceed 1.5 degrees warming this decade and 2 degrees before 2050. The numbers from last year are particularly dire. The global temperature average was 1.48 degrees Celsius above pre-industrial level. Close to 50% of the days were more than 1.5 degrees, and 2 days in November broke 2 degrees warming for the first time ever. On the right is a graph of monthly global surface temperature since 1940. The decades kind of, the ones that are in 1940s are in the dark mass at the bottom, and they get lighter as they go up. So the lighter color ones are closer to the top. The yellow line is last year. You can see in June, July, it skyrocketed to way above anything previously recorded. Now, part of this is due to the El Nino effect, which does raise the temperature. And it did start, El Nino did start in June. However, this graph includes 20 other El Ninos that have happened since 1940, and none of them have passed the 1.5 warming mark. The red on the right is up to February of this year, and you can see that we are continuing the warming into this year. And it is expected to continue until El Nino passes, which I believe is expected in August. This is a chart of the daily sea surface temperatures from 1981 to present. The vast majority of our carbon emissions are sucked up by the ocean, the result being that the oceans are dramatically warmer than they were a few decades ago and much warmer than they were even a year ago. So here, the orange line is the 2023 temperatures. The dashed line in the middle of the two other dashed lines represent the mean temperature of 1982 to 2011. And then the solid black line on the top left is how we're running so far this year. The amount of energy that we're putting into our oceans is so vast that it can be compared to the amount of energy released in an atomic bomb explosion. And so we're currently putting the equivalent of almost 13 Hiroshima bombs into the ocean every second. So we can't save everything. Moreover, given that digital preservation uses finite resources, it's not ethical to preserve everything. I was really pleased yesterday to see the talk on retention periods. Retention periods are a critical tool that have been used in records management and archives for millennia. The ancient Mesopotamians used to classify records according to how long they were kept. And it's really, this classification is really a useful tool to make sure that we're not keeping data beyond what's necessary. And based on the discussions I've had with researchers, most data does not need to be preserved indefinitely. And it's extremely important to decide the retention period of the data prior to its ingest into a repository, and to have that documentation somewhere, either in the descriptive metadata or as like a README file, excuse me, because once the data is deposited into a repository, inertia will likely keep it there. It's extremely time consuming to go back 3 or 5 or 10 years and ascertain if the data still has value. And I'm not sure actually how integrated this practice is in repositories. In my own situation, we don't actually do it. We reserve the right to remove data from our collections, but we don't have deaccessioning plans or methods in place to assess the value or history of the use and the steps needed to take to dispose of the data. But I'm not saying that there's no data worth keeping indefinitely. Excuse me. So for example, at UC San Diego, we steward the Keeling curve data, which consists of continuous measurements of carbon dioxide levels in the atmosphere since 1958, and actually helped alert us to the increase of carbon in the biosphere. So there is data that I think is particularly useful, longitudinal data, especially, that we should preserve into the future. But knowing the risks that we face due to climate change, what strategies can we employ to preserve these materials? Well, first you'll want to encapsulate your data, which is just a way of saying it should be packaged into an independently understandable APE or archival information package. Bagot is a great tool to use, and I'll briefly touch on it in the next slide. You want to use non-proprietary, widely used, lossless, unencrypted file formats if possible. I included the UCSD preferred file format list as an example, but your institution probably has one as well. Implementing the FAIR principles will help with providing some of the metadata needed for long-term preservation. You want to clearly indicate any software dependencies needed to interpret the data. You can even include the software and dependencies in the package. Include a PDF of any relevant journal articles. Do not expect links out to journal articles or to or even the long-term preservation of the journal article itself. It should be all encapsulated in one package. And there is a link on this slide to a recent article about like 25% of journal articles not being accurately preserved. So Bagot is a set of hierarchical file system conventions designed to support storage and network transfer of digital content. A bag consists of a payload and tags, which are metadata files to document the storage and transfer of the bag. So I have a bit of the Bagot structure on the left here. You can see that it's human readable. You can look at it and kind of get an idea of what's in the bag itself. That's extremely important. And you can look through and see that it includes the manifest, and the manifest also includes the MD5 hash. The hashes associated with the data inside the bag. The Bagot structure is widely adopted in digital libraries, and also provides a tool for interoperability. And one of the things that is especially great about it is that you can maintain the desired directory structure of the data itself. And so the next slide is that don't depend on one repository or repository service. You basically don't want any single points of failure, and a repository service is a single point of failure. You should inspect the services that you're using to identify any redundancy. For example, a lot of services use AWS in their infrastructure. And you want to think about diversifying the storage type. So the hardware, what it's stored on, as well as things like payment options. Do you have to pay annually, or can you pay for digital preservation storage for 20 years up front? And then there's some newer options available too, things like Filecoin. DNA storage is still pretty exploratory, but if you have very important data, it is definitely something worth considering. And I'm over time, but one of the things that became really apparent to me as I was digging into this is that our institutions are, incredibly at risk. We're on track to reach 3 degrees Celsius by the end of this century. And basically by that point, all bets are off. And so it wouldn't necessarily just be our institutions, but, our university, but all universities. So how do we hedge against this if you decide that it's worth trying to hedge against that path that we're particularly on? And the idea is really to go rogue. And so that's to shift our thinking beyond the normal preservation strategies, beyond the partners that we normally partner with, and try to actually create scenarios that that create a picture of what the world could be like. Our Western industrial society is incredibly vulnerable, and at the rate of warming we are on today, we cannot expect the future to look anything like the past. Thank you.
Thank you, Sybil. And thank you everyone who's presented so far. I welcome all of our presenters to come back on. It is our question and answer segment of this session. I don't have any open questions at the moment. I will note that there were a couple questions that were answered during the presentation. This was a really great session, everyone. I don't know if you noticed while everybody was presenting the reactions that were popping up. That's great. Okay. I think everyone should have the ability to safe chat if you want to do that. We don't have any other questions, so I guess we can call this a wrap. I want to thank all of our presenters for participating in this section. I believe the next session, 5B, Making Connection, is going to be on this same Zoom link. I believe you're welcome to stay on during the 15-minute break.
Yep, the room will stay open. If you want to attend 5A, that will be in a different Zoom room that you can get from Feedloop.